name is Paula and I'm a process engineer out in Intel Ireland. If you go to the next, do I have a pointer? I see it, sorry, very technical. Okay, so who am I? So, as I said, my name is Paula and I'm from Dublin originally. I went to Mount Sackville Secondary School in Chapel Izzard, which is, I don't know if I have a pointer, but it's up in Castleknock, so it's around the kind of West Dublin area. So, although I'm a process engineer, I'm not actually really technically an engineer. I guess science is actually my background. And I always enjoyed kind of seeing how things worked, kind of finding out a lot about things, and just kind of, finding out more information about things. And that's one of the reasons why I decided to do science for the Leaving Cert, because I found it kind of just fascinating. It was not by far my best subject. And I think that's one of the things, there can be a bit of a misconception that in order to do science in university, to do it in college, that you need to have really good grades. Don't get me wrong, you need to pass your exams, but you don't need to be like the best student in the class, you don't need to be getting A's and B's. As long as you have an interest, as long as you have something, that kind of sparks your interest, that keeps you going. And that's what I had when I decided to do science. Now, I never actually had a very clear career path. I had friends that knew for sure, sort of, when they were in school, like they wanted to be a teacher, they wanted to be a solicitor, an accountant, and I never knew that. I sort of had no clear path in sight. So when it came to deciding what I would do in university, I knew that I enjoyed the science subjects, I knew that they were interesting, and I knew it was, if I did science as a degree, it was quite a general topic, that I wouldn't be too pigeonholed, that I'd still have lots of options available. So I came to Trinity College here and I did a general science degree. And I picked, the subjects I did was physics, chemistry and maths. And I really liked the fact that as you progress through the degree, that you pick the subjects that you're interested in, and eventually you specialised in something a little bit more than just general science. My degree at the end was the physics and chemistry of advanced materials, which is now the nanoscience course. And when I was in my final year, for my fourth year project, I had an opportunity to go to San Diego for about 3 months to work in a research lab out there. And I found that really interesting, to actually get some hands-on experience of working in science and doing experimentation. And I enjoyed it so much that I decided, once I came back and I finished my degree, that I'd like to pursue sort of research a little bit more. So I ended up doing a PhD, a postgraduate degree, a PhD in the physics department, again here in Trinity. Feedback. I did a PhD. It was in the optical properties of micro and nanomaterials. And I really enjoyed that. But at the end of my time, I realised, much to my parents' delight, it was time to leave college and get a real job. So I really wanted to use something that, or to work at something that I could use what I learned, the skills that I learned in college, and sort of that would kind of maintain the interest in learning and finding out about things. And when I finished, I was very, very lucky that Intel at the time was looking for people, so it seemed like a perfect fit. So as many of you know, Intel is a multinational company. We have sites and offices around the world. The main manufacturing sites there's 3 or 4 in the US. We have one here in Ireland, one in China, and one in Israel. So we are based out in Leixlip. So if we go back a slide, so you can see the top, I don't have a pointer, but the main site is based out in Leixlip. And what we do is we manufacture, as you probably know, we manufacture a microchip. And very, very basically, the microchip is the brains of your computer. So when you push a button or press a command on your computer, it is this microchip that processes that command. And the way, very, very basically, the microchip, it's built up with layer upon layer that makes up the circuit that eventually becomes the microchip device. And the size of these layers are very, very small. They're so small that we can't see them by eye. If you think of the width of a human hair, the layers that we print are about 10,000 times smaller than the width of a human hair. You're talking nanometer scale. So it's very, very small. And as you can imagine, working on things that are this small, they're very, very sensitive. They're very easy to damage. And this is why in Intel, when we're working in the factory, we must wear this very attractive bunny suit. And it's to protect the microchip, it's to protect the layers. Any kind of hairs, any dust, any skin cells that we can bring in will damage the microchip. So what my job is, I'm what's known as a layer owner. So you basically, to build up the device, it's hundreds and hundreds of layers. And my job is a tiny subset of these layers. I'm in charge of making sure that they're printed correctly, that they're in the right place, that they look right, and that they're doing the job that they're meant to do. So it's basically, a lot of it is kind of quality control. There's also a lot of problem solving involved in it. So an awful lot of the times it's a bit like CSI. You know, something has gone wrong, you need to figure out what it was, why it went wrong, how you can stop it going wrong again, and sort of how you can fix it. There's also an awful lot of sort of learning from different areas, different groups. You're always learning, which is something that I really like. So you work as parts of groups, and people come from different areas, different backgrounds, they have different levels of experience. There's people from different areas of science, different types of engineering, different industry experience, and you all come together and you can all bring something different to the pot to help solve these problems. So every day is different, and I think that's one of the things that I love most about this job, is that you never know what's going to happen, you never know sort of what you're looking for, if something has gone wrong. And there's also an awful lot of improvements that you're always doing. So you have procedures in place that how to do a certain specific job, and you're always looking for ways of improving that. How can I make that better? How can I make it possibly cheaper? How can I make it more efficient, basically? So that's pretty much what my day-to-day job entails. So what do I love and what do I hate about Intel, or working for Intel? So I guess I wouldn't say hate, but I think one of the things that kind of can take an awful lot of getting used to is that it's quite a dynamic environment. Things are always chopping and changing quite a lot, and it can take a bit of getting used to. So whether it be that there's a process change and you must make sure that sort of, you know, you're on top of it, you know what's going on, or perhaps maybe, I don't know, your customers say they all of a sudden by tomorrow they need so many more microchips out the door. You have to be able to make sure that you can ramp up to get those microchips out the door. So sometimes you feel like this poor person, making sure you've got all their plates spinning in the air as they get added to and taken away from, and making sure the plates don't fall. I think one of the things I love most about the job is the idea that you're working on something that affects everyday lives, and you're hopefully working on something that improves everyday lives. So we all know Intel microchips, they go into computers, they go into laptops, mobile phones, but it also goes into other areas you wouldn't necessarily know about. So different types of machinery, equipment in hospitals, for spaceships. Even an example here I have is some car manufacturers use Intel microchips in their onboard computers, even down to silly things. I wouldn't say silly, but even down to such level that Coca-Cola actually uses Intel microchips in their vending machines. And I think that's fascinating, that you're working on something that everyone uses, and that's hopefully improving everyone's lives. So that's my talk, and thank you very much.